Promax Combustion. Fire done safely.
Hello everyone, and welcome to Promax University. This is the first module in our Safety Shutoff Valve series discussing the safety equipment within your combustion system. Before we dive into too much detail, it is important to point out that all of our presentations are geared towards industrial combustion applications. We're going to centralize our discussion around two main points. One, current regulatory bodies with jurisdiction in Canada, and two, regulatory categories of safety shutoff valves. There are only two regulatory bodies with jurisdiction in Canada regarding safety shutoff valves for combustion systems. The Canadian Standard Association, more commonly known as CSA, is a global organization dedicated to safety, social protection, and sustainability. They are the Canadian leader in standards development, testing, inspection, and certification. Underwriter Laboratories Canada, more commonly known as CUL, is an independent product safety testing, certification, and inspection organization. They are fully accredited by the Standards Council of Canada. On the international scene, Factory Mutual, FM, Underwriter Laboratories in the US, and CE for Europe, among others, are all known insurance or certification or inspection agencies with accreditation. However, it's extremely important to know that these approvals or accreditations have zero relevance here in Canada. They are not recognized as acceptable when it comes to safety shutoff valves within combustion systems. Safety shutoff valve approval categories can be subdivided into three main groups. First and foremost, we have the typical combustion system that uses natural gas or propane. Both CSA 149.1 and CSA 149.3 clearly outline the requirements when using these fuels. Note these codes are for the field approval of appliances, so these rules don't always apply to the off-the-shelf heaters sometimes used in warehousing or makeup air heaters. The next group of approvals would be linked to biogas systems. CSA 149.6 is the recognized Canadian code for digester, landfill, and biogas systems. Last but not least, fuel oil safety shutoff valves are determined by the requirements of CSA 139, the Canadian code for oil burning equipment. Before we dive into the classification and certification of safety shutoff valves, it's important to first define what exactly a safety shutoff valve is when used on natural gas or propane systems. As given by CSA 149.3, a safety shutoff valve is a valve that automatically shuts off the supply of gas when de-energized by a combustion safety control, a safety limit control, or loss of actuating medium. In other words, if you need to stop gas flowing into your burner, either intentionally or because of an emergency, it is a safety shutoff valve that automatically takes care of it for you. Safety shutoff valve regulation varies depending on whether it is used as a pilot or main gas line, and depending on the maximum firing rate of the appliance itself. This is extremely important to remember. The physical size of the valve is irrelevant to the certification required. It is the firing rate of the appliance that determines the level of certification. Certifications fall under a plethora of classifications like CGA 3.9, CSA 6.20, 6.4, 6.5, and 6.5 C/I. When it comes to the classes of safety shutoff valve certifications, the intent of this presentation is not to bore the listener into submission. Some classifications are an indication of age, like CSA 3.9 that was replaced in 2005, or CAN 1 6.4 that dates back to 1979. Others are an indication of functionality, like CSA 620 that deals with multifunction safety shutoff valves. The two most important classifications regarding industrial combustion systems involve CSA 6.5 and now CSA 6.5 C/I. They are essentially the same code, but the C/I is an additional certification that indicates the safety shutoff valve is approved for commercial and industrial applications. It is important to mention that the diagrams that follow in this slide and the next couple of slides only show the minimum code requirements. Promax Combustion recommends that 2 safety shutoff valves in series always be installed regardless of the minimum code requirements. Looking at pilot lines with capacities under 20,000 BTUs per hour, one can see that the safety shutoff valve requirement is a single CSA 6.4 or CSA 6.5 certified valve. If we increase the overall capacity of the pilot line to greater than 20,000 BTUs per hour, but less than 400,000 BTUs per hour, the minimum code requirement is now either a dual safety shutoff valve with CSA 6.5 approval or a single safety shutoff valve with CSA 6.5 C/I certification. If we increase the overall capacity of the pilot line to greater than 400,000 BTUs but less than 3.5 million BTUs, the minimum code requirement is now dual safety shutoff valves, with one having CSA 6.5 C/I and one having CSA 6.5, or a single safety shutoff valve with CSA 6.5 C/I with proof of closure switch. The switch must be wired into the pre-ignition interlocks of the flame safeguard controller. For pilot lines above 3.5 million BTUs per hour, it should be treated as a main gas line when it comes to code requirements. Main gas lines are treated in a similar manner to the pilot gas lines, except that overall capacity requirements are at different thresholds. The smallest family of main gas valves are for systems under 200,000 BTUs per hour and at operating pressures of less than 0.5 psi. Under these conditions, a single safety shutoff valve can be either CSA 6.4 or 6.20 with various configurations. For appliances with capacities of less than 200,000 BTUs per hour, but at operating pressures greater than 0.5 psi, code requires dual safety shutoff valves with CSA 6.5 or a single safety shutoff valve with CSA 6.5 C/I. For appliances greater than 200,000 BTUs per hour, but less than 5.0 million BTUs per hour, dual safety shutoff valves with CSA 6.5 C/I approvals are necessary, or a single shutoff valve with CSA 6.5 C/I and a proof of closure switch incorporated into the pre-ignition interlocks. For appliances greater than 5 million BTUs per hour, but less than 12.5 million BTUs per hour, dual safety shutoff valves with CSA 6.5 C/I approvals, and one valve that incorporates a proof of closure switch into the pre-ignition interlocks is required. For appliances greater than 12.5 million BTU per hour, dual safety shutoff valves with CSA 6.5 C/I approvals and incorporating a proof of closure switch into the pre-ignition interlocks is a requirement. At these larger capacities, we also see the necessity of either a vent valve or a valve-proofing system installed in between the main shutoff valves. These examples are for single burner applications only. There are varying requirements for multi-burner applications, but the ideology that is used here is similar. We have run through these different scenarios very quickly. The intent of this presentation is simply to outline that appliance capacity is the driving force behind the required safety shutoff valve certification. It is essential to refer back to the code requirement when planning your projects to make sure that your safety shutoff valves are appropriately chosen. Biogas systems are treated in a similar manner to natural gas and propane appliances, except that the code requirement does not vary with appliance capacity. If fuel composition is constant, then dual CSA 6.5 C/I safety shutoff valves are required. If the fuel composition is not controlled, then proof of closure switches must also be incorporated into the pre-ignition interlocks. Oil-fired safety shutoff valves must meet the requirements of CSA 139. Typically, CSA C22.2 number 139, the standard for electrically operated valves, is sufficient as long as the valves meet the flow, pressure, and fuel type required for a given appliance. It is typical to install 2 valves in series. So, what have we learned? CSA and CUL are the only regulatory bodies having jurisdiction in Canada with regards to safety shutoff valve certification. Natural gas and propane systems, biogas systems, and fuel oil systems all have different certification requirements. Shutoff valve requirements are typically dictated by the maximum firing rate of the appliance.